This video has sound. Hopefully everybody can hear me. Otherwise, I want everyone to make sure they can hear the sound. So I'm going to point at this sign to hopefully make sure they get it going. Alright, so this is a lesson on 12.3.2. That's chapter 12, section 3, part 2. We're going to be finding the surface areas of cones. This is out of the chapter 12 geometry study guide. Some vocabulary to get us started. A cone is like an ice cream cone in the traditional shape. It is a three-dimensional solid with a circular base and a vertex. Vertex is a point. So there's your point. So here's the circle on the bottom, and there's the vertex at the top. Now I say bottom and top because we tend to talk about cones in this orientation, meaning that the point is at the top and the circle's on the bottom. Normally when we hold an ice cream cone, it's the other way around, but this is the way that we usually think about cones in math. The vertex, again, is just the point at the top of the cone. A right cone is a cone where if you drop a line straight down into the center of the object from the vertex straight down, it meets the base circle at a right angle. And then we've talked a lot about lateral surface area, or lateral surfaces. It's basically the sides on a shape. So this part here is the lateral surface. Okay, so the formula for the surface area of a right cone is very similar to the pyramid work that we did in the first part of section 12.3. And that is to say that we find the area of the base. Before, the base was some sort of polygon. This time it's a circle. So the area of a circle is just pi r squared, right? Plus 1/2 times the circumference, which is the same as perimeter, but just for circles it has a special name. Circumference of a circle is 2 pi r. That's your circumference. And then the lateral surface, the L stands for the slant height. Remember on the pentagon, or the pyramid, excuse me, the pyramids, the L stood for the slide down the side height, right in the middle of one of those lateral surfaces, right? Well, on a cone, you're still sliding down the side. It's just whatever the distance is from the vertex sliding down to the bottom, to the base. So very similar to what we did with pyramids. L, again, is your slant height, or as I call it, the slide down height. All right, so if we use this formula, here you can see the radius is 3 meters and the slant height is 5 meters. The surface area here, again, you can call it SA or S, doesn't matter, would be area of the base, pi r squared, plus 1/2 times the circumference, which is 2 pi r, times the slant height, which is L. So that would be pi times 3 squared, plus 1/2 times 2 pi times 3, times the slant height of 5. So that's 9 pi, because 3 squared is 9. And then the half and the 2 would cancel each other out, and then 3 times 5 is 15 with the pi. So basically you have 24 pi if you add 9 pi plus 15 pi, which is approximately, if you multiply 24 times pi in your calculator, 75.4 square meters. Same basic thing down here. The surface area would be area of the base, which is the circle area, pi r squared, plus 1/2 times the circumference of this circle, which is calculated by 2 pi r, times the slant height, which is L. So this would be pi times 6 squared, plus 1/2 times 2 pi times 6, times the slant height of 10. So 6 squared is 36, so this would be 36 pi. The half and the 2 would cancel each other out. 6 times 10 is 60 with the pi. And then 36 pi plus 60 pi is 96 pi, which if you multiply 96 times pi in your calculator, you get approximately 301.59 square feet. Remember when you're using pi, if you don't for some reason have a pi button on your calculator, and you all should, but if for some reason you have a very, very, very simple calculator that doesn't have a pi button, remember to use 3.14159. Don't just use 3.14, because you're going to get answers that are kind of close to the right answer, but not exactly right when you're rounding off to 2 places. Okay? All right, a few more examples on the next page. So here they've given us again the radius and the slant height. So the surface area would be area of the base, which is pi r squared, plus the 1/2 times the circumference of the base, which is 2 pi r, times the slant height. So that would be pi times 8 squared plus 1/2 times 2 pi times 8 times the slant height of 15. So that 8 squared is 64, so that's 64 pi. These two cancel. 8 times 15 is 120 with your pi. So 64 pi plus 120 pi is 184 pi, which 184 times pi in my calculator is 578.05. And this is a surface area, so it's meters squared. The next example doesn't have a number. We'll call this number 11, and then this one number 12. Number 11, the base is at the top, and they don't give us the radius. What they do is they give us the entire diameter. So if this is 14 all the way across, then this length right here is 7, and this length right here is 7. Now, again, this cone is upside down, so the base is at the top, which means that the slant height, which would be sliding from the top vertex down to the bottom, would be here. They don't give that to us. So in order to find the slant height, what we're going to do is just take this right triangle right here, and we're going to say we have the 2 legs, but we don't have the hypotenuse. So we're going to use the Pythagorean theorem. Just going to redraw it over here. This is my L. This is 7 up here. And this is 11 right here. So leg squared plus leg squared equals hypotenuse squared. It'll give me 49 plus 121. So your leg squared, if you add those two together, is 170. So we're going to take the square root of both sides. So our slant height is approximately 13.0384. Now I think that's all I need. I have the radius of my base, which is 7. And now I've calculated the slant height. Again, this object is upside down. Of 13.0384. So my surface area is area of the base, I have the radius now, plus 1/2 times the circumference, which I now have the radius for, times the slant height, which I now just calculated. So pi times 7 squared plus 1/2 times 2 pi times 7 times the slant height of 13.0384. So that will give us 7 squared is 49. So this is 49 pi, my first term. The 1/2 and the 2 cancel each other out. So it's just going to be 7 times 13.084, which is 91.26883367, and then the pi gets placed at the end. And if I add these two numbers together, I get about 140. 0.2688337 pi. So if I multiply this decimal times pi, I get a surface area of about 440.67 square feet. The last example, again, they did not give me the slant height. This is a cone that's knocked over, the base is here and the top is here. So they gave me the radius, but they did not give me the slant height. Right there, that's the slide down the side of the cone to the base height. So I can think of this internal triangle as a right triangle, which it is, and I can use it to find the fact that it's a right triangle, to use my Pythagorean theorem to find this side here, which is the hypotenuse. So if I use leg squared plus leg squared equals hypotenuse squared, I can calculate my slant height here. So my slant height is approximately 26.9258. So to find the surface area, that would be pi times radius squared plus 1/2 times the circumference of your circle at the base times the slant height. So the radius of this base is 10. So it'd be pi times 10 squared plus 1/2 times 2 pi times 10 times the slant height of 26.9258. So I get about 100 pi plus 269.258 pi, which is about 369.258 times pi. So multiplying those two things on my calculator gives me approximately 1,160.06 square centimeters.